solar eclipse happens when the moon's shadow falls somewhere on the surface of Earth. And a lunar eclipse is the opposite, when the Earth's shadow falls across the moon. Total eclipses occur within the darkest part of that shadow, the umbra. In the lighter part of the shadow, the penumbra, we get partial eclipses. So that's the short explanation. But you might wonder why we don't get eclipses every month, given that the moon orbits Earth every 29 days or so. The first reason is that the moon's orbit path is not in line with the Earth's orbit around the sun. It's tilted 5 degrees. That doesn't seem like much, but keep in mind that the model we're showing to you is way off. If the Earth and the moon are this size, the distance between them should be around 10 feet. So at this distance, 5 degrees is enough to keep the moon's shadow off of Earth and the Earth's shadow off the moon most of the time. So why do we ever get eclipses? Because there are 2 points where the moon's orbit crosses the sun's plane, called nodes. And as the Earth moves along its orbit, these points line up with the sun about twice a year. If the moon is between the sun and Earth at that time, we get a solar eclipse. If it's behind Earth at that time, we get a lunar eclipse. In a total solar eclipse, the moon completely covers the sun from the vantage point of some place on Earth. This is possible because, by coincidence, the sun and the moon appear to be the same size in our sky. While the sun is 400 times bigger than the moon, it's also 400 times farther away. The moon has an elliptical orbit though, so its size varies about 12% throughout the month. At its closest distance, we can get total solar eclipses, but when it's farthest away, we can get annular eclipses, where a ring of sunlight remains around the moon. In the far future, Earth will only get annular solar eclipses. We know that because Buzz Aldrin and Neil Armstrong left mirrors on the moon in 1969. Astronomers bounced lasers off those mirrors to measure the moon's distance, and that's how they found out that the moon is moving away from us about 1.5 inches every year. So at some point in the future, we're talking like 600 million years from now, whatever creatures live here will witness Earth's very last total solar eclipse.
We can see on the radio on the screen a fantastic total solar eclipse taken from the pictures above the clouds.
Den Chef der Sternwarte in mir. Was fühlt man in so einem Moment, Herr Philemon?
This is just fantastic.
The totality lasts no longer than 7.5 minutes, and although Earth gets an eclipse like this every 18 months on average, each one is only viewable by less than 0.5% of Earth's surface. Eclipse chasers will travel all over the world to put themselves in the path of that shadow. You're much more likely to see a total lunar eclipse in your lifetime. They can last an hour and 40 minutes, and they're viewable for anyone on the night side of Earth. During a total lunar eclipse, the moon often turns red. If we didn't have an atmosphere, the moon would go completely dark, but the gas molecules in our air scatter the shorter, bluer wavelengths of light, while the longer, redder wavelengths pass through to the moon. Or to put it another way, during a total lunar eclipse, the sun projects all of the world's sunsets and all of the world's sunrises onto the moon at the same time.